Try SMTP interaction for yourself. Telnet server name 25. C220 reply from server. Enter hello mail from receipt to data. Put commands. Above lets you send email without using email client reader. So SMTP final words. SMTP uses persistent connections. SMTP requires message header and body to be in 7-bit ASCII. SMTP server uses CRLF to determine end of messages. Comparison with HTTP pull, SMTP push. Both have ASCII command response interaction status codes. HTTP each object encapsulated in its own response messages. SMTP multiple objects sent in multi-part message. Mail message format. SMTP protocol for exchanging email messages. RFC 822 standard for text message format. Header lines example 2 from subject. It is different from SMTP commands. Body the message ASCII characters only. Header blue is body and empty space is a blank line here. Message format multimedia extensions MIME. Multimedia mail extensions RFC 2045, 2056. Additional lines in message header declare MIME content type. And MIME version 1.0 is a MIME version. Content transfer encoding base 64. The method used to encode data. Content type image / JPEG. Multimedia data type subtype parameter declaration. Base 64 encoded data is a encoded data. Mail access protocols. Manipulation of stored message on server. HTTP Hotmail, Yahoo, email, etc. POP3 protocol. Authorization phase. Client commands. User declare username, password, and server responses OK plus OK minus error. Transaction phase client list messages numbers. RETR retrieve message by number. Delete and then quiet. POP3 more and IMAP. More about POP3s are previous examples uses download and delete mode. POP that cannot be reread email if he changes client. Download and keep copies of messages on different clients. POP3 is stateless across sessions. IMAP keep all messages in one place. The server allows user to organize messages in folders. IMAP keeps user state across sessions. Names of folders and mapping between messages, IDs and folders name. DNS is a domain name system. People, many identifiers, SSN, name, passport number, and internet host routers. IP address 32-bit used for addressing datagrams. Name example www.yahoo.com used by humans. Domain name system. It is a distributed database implemented in a hierarchy of many name servers. Application layer protocol host routers name servers to communicate to resolve names address / name translation. Note core internet function implemented as application layer protocol. Complexity at network's edge. DNS services host name to IP address translation. Host aliasing canonical and alias names. Mail server aliasing. Here load distribution replicated web servers set of IP addresses for one canonical name. Why not centralized DNS? Single point of failure, traffic volume, distant centralized databases, maintenance. And distributed hierarchical database, root DNS server, com DNS server, org DNS server, edu DNS servers. In .com DNS servers, yahoo.com DNS servers, amazon.com DNS servers, and pbs.org DNS servers, edu, poly.edu, umas.edu DNS servers. Client wants IP for www.amazon.com. First approximation is client queries a root server to find com DNS server. Client queries com DNS server to get amazon.com DNS server. Client queries amazon.com DNS server to get IP address for www.amazon.com. DNS root name servers contacted by local name server that can not resolve name. Root name server contacts authoritative name server if name mapping not known. Gets mapping returns mapping to local name server. 13 root name servers in worldwide. TLD and authoritative servers top level domain server responsible for com, org, net, edu, etc. and all top level country domains UK, FRCAJP, network solutions maintenance servers for com TLD, authoritative DNS servers, organizations DNS servers providing authoritative host name to IP mapping for organization servers, example web and mail, that can be maintained by organization or service provider. Local name server does not strictly belong to hierarchy. Each ISP, residential ISP, company, university has one, also called default name server. When a host makes a DNS query is sent to its local DNS server that acts as a proxy, forwards query into hierarchy. Example, it is a root DNS server. Step 1, requesting host to the local DNS server dns.poly.edu. It is forwarded to the root DNS server and DLS DNS server it is receiving, and then finally given to the local DNS server. Then it is passed to the authoritative DNS server dns.cs.umas.edu. Finally gac.cs.umas.edu. Host at cspoly.edu wants IP address for gaia.csumas.edu. Recursive query puts burden of name, resolution of contacted name server is a heavy load, and in iterated query, contacted server replies with the name of the server to contact. I don't know this name but ask this server. DNS caching and uploading records. Once any name server that lands mapping catches mapping, catch entries timeout disappear. After some time, DLD servers typically catched in local name servers, thus root name servers not often visited. Update or notify mechanisms under designed by IETF, that is RFC 2136. DNS records, DNS, distributed DP, storing resource records, RR format, name, value, type TTI. Type A, name is host name, value is IP address, type is equal to NS, name is domain, example food.com, value is IP address of authoritative name server for this domain, type is equal to cname, name is alias name for some canonical, the real name, www.ibm.com is really, serverized backup2.ibm.com, value is canonical name, type is equal to mx, value is name of the mail server associated with the name. DNS protocol messages. DNS protocol query and reply messages both with the same format. Message header, identification 16-bit for query, reply to query uses the same flag, same number, flag query or reply, recursion desired, recursion available, replies authoritative. Identification flag, number of questions, number of answers, and number of authority errors, number of additional errors. The above are used 12 bytes. Questions, variable number of questions, answers, variable number of resource records, authority, variable number of resource records, additional information, variable number of resource records. DNS protocol messages, name, type fields for a query, and RRs is responsible to query answers. For authority, records for authority servers, additional information, that is helpful information that may be used. Inserting records into DNS, example, just created a startup network Utopia, register name network utopia.com at a register, example, network solutions, need to provide register with the names and IP addresses of your authoritative name server, primary and secondary. Register, insert 2 RRs into the com DLD server, put in authoritative server, type A, record for www.networkutopia.com and type mx record for networkutopia.com.